Hello grade 9. In last video we talked about some of polynomial functions like constant function and linear function. In this video we will talk about the quadratic functions, okay? The quadratic functions, what is the meaning of it? F is a function where f is a function from R to R to R, where fx equals ax power 2 plus bx plus c. Here, the rule of the function of the quadratic function is ax power 2 plus bx plus c, okay? And the domain and the codomain belong to real numbers. A, P, and C are real numbers, okay? Where A not equal to 0 must be A not equal to 0, because if A equals 0, this function, okay, becomes what becomes linear function. So A must be not equal to 0. This function is called quadratic function, and it is a function of the second degree. Because what? Because the index or the highest index of x is 2, okay? Therefore, this function is a function of the second degree. For example, here, f is a function from R to R, where fx equals x power 2. Also, f is a function from R to R, where fx equals x power 2 minus 2. F is a function where from R to R, where fx equals 3x power 2 minus 7x plus 2. And we know something, the highest index of x is 2. Therefore, each function of them is a function of the second degree, okay? Now, I need to represent the quadratic function graphically, okay? Here, I said before, the domain belongs to real number. So, when we represent it graphically, we should represent it on interval. Because what? Because I said the domain belongs to real number, so we should represent it on interval by determining sum of order pairs which belong to the rule of functions, okay? Then we can draw the curve passing through these points to show the curve which represents this function, okay? For example, here, example number 1, represent graphically the quadratic function f, where fx equals x power 2 and x belongs to real number. Consider x belongs to this interval, okay? X belongs to this interval, closed interval, -3 and 3, okay? Now, I need to find sum of order pairs which belong to this function, okay? Now I can substitute by any value of x which belong to this function. But to make it easy, I will substitute by integer numbers which belong to this interval, okay? So the integer numbers which belong to these intervals are -3, 2, 3, 2, 1, 0, -1, -2, -3, okay? This is the integer numbers which belong to this interval, okay? Now, I will substitute by each value of x in this rule, okay? So when x equals 3, fx equals what? Equals 9, so y equals 9. Also, when x equals 2, y equals 4. When x equals 1, y equals 1. When x equals 0, fx equals also 0. And when x equals -1, y equals 1. When x equals -2, fx equals 4. Also, when x equals -3, y equals what? Equals 9. Now, label each order pairs on the perpendicular square net like this, okay? 3, 9, here, 2 and 4, 1 and 1, 0 and 0, -1 and 1, -2, okay? -2 and 4, and also -3 and 9, okay? Here, we know something from the curve. The line, the y-axis here is the line of symmetry of this curve, okay? Line of symmetry. Y-axis is the line of symmetry of this curve, okay? And from the table, okay? Here I have 7 order pairs, okay? The middle order pair here, 0 and 0. This is the middle order pair here represent the point of the vertex of the curve, okay? So the point 0 and 0 is what? Is the point of the vertex of the curve. So the coordinate of the vertex of the curve is 0 and 0, okay? So here I have 7 order pairs. 9, 9, 4, 4, 1, 1. The middle order pair 0 and 0 represent the point of the vertex of the curve, okay? Now I need to find the equation of the line of symmetry. I said here, y-axis divide the curve into 2 parts. So the y-axis is line of symmetry of this curve, and the equation of line of symmetry equals what? Equals x equals 0. X equals 0 because what? Because the x coordinate here, the value of x coordinate equals 0. So the equation of symmetrical axis is x equals 0, okay? The value of x coordinate. Now, I need to find what? To find I need to find something. The minimum value of function. The minimum value of the function. Minimum value of the function equals 0. To find the minimum value of the function equals y coordinates of the point of the vertex of the curve. I said the point of the vertex of the curve is 0, 0. Here y coordinates, okay? The value of y coordinates here equals 0. So the minimum value of the function equals 0, okay? And we know something from the function here. Fx equals x power 2. The coefficient of x power 2 is a positive number. So I mean the coefficient of x power 2 greater than 0. When the coefficient of x power 2 greater than 0, we note the curve lies up the point of the vertex of the curve. And this point here, 0 and 0, okay, 0 and 0 is the point of the vertex of the curve, or the minimum value point, okay? We know the curve lies up on it, okay? So the minimum value of the function equals 0 equals the value of y coordinates. Number 2, in this exercise here, if fx equals negative x power 2, negative x power 2, and x belongs to R, consider x belongs to the interval negative 3 and 3. The same idea here, I will substitute by the integer numbers which belong to this interval in this function, okay? So the integer numbers which belong to this interval are 3, 2, 1, 0, negative 1, negative 2, negative 3. When I substitute by the value of x in this rule, we get when x equals 3, y equals -9. When x equals 2, y equals -4. Also, when x equals 1, y equals -1, and so on. Then I will what? I will label each order pairs in the perpendicular square net like this, okay? Like this. Then I will draw the curve passing through these points which represent this function. Now we note something. Here in this table, from this table, I have 7 order pairs. The middle order pair here, 0 and 0. Take care, -9, -9, -4, -4, -1, -1. The middle order pairs here, 0 and 0. And this order pair represent the point of the vertex of the curve. So the point of the vertex of the curve is the origin point here, 0 and 0, okay? And we note y-axis is the line of symmetry of this curve. Y-axis is line of symmetry of this curve, okay? Now, the coordinate of the vertex of the curve is the order pair 0 and 0. Now, I need to find something, okay? First one, the equation of symmetrical axis. The equation of the symmetrical axis, okay, equals, I said the equation of the symmetrical axis equals the value of x coordinates of the point of the vertex of the curve. Here, the value of x coordinates of the vertex of the curve is x. So the equation of the symmetrical axis is x equals 0, okay? And the maximum value. Here, this curve has maximum value or minimum value. Has maximum value point. Because what? Because here the coefficient of x bar 2 is a negative number. I mean the coefficient of x bar 2 less than is 0. Okay? So the point of the vertex of the curve or the maximum value point 0 and 0. Here we note something. The curve lies below at this point here, the maximum value point, okay? The curve lies below at, okay? So this curve has the maximum value point, and the maximum value of function equals the value of y coordinates in the vertex of the curve. The value of y coordinates in the vertex of the curve equals 0. So the maximum value of function equals 0, okay? So when the coefficient of x power 2 is a negative number, the function has the maximum value of the function. But when the coefficient of x power 2 is a positive number, the function has the minimum value of the function, okay? Another exercise here, example number 2. Represent graphically the quadratic function f, where fx equals x power 2 plus 2x minus 3, okay? So the rule of the function is x power 2 plus 2x minus 3. Here, x belongs to R. Consider x belongs to what? Belongs to closed interval -2 and 4. From the graph, find something, okay? First one, the maximum or minimum value of the function. The equation of line of symmetry. Before I will solve this problem. Here, the coefficient of x power 2 is positive number. So this function have maximum or minimum value? Good, has minimum value of the function because the coefficient of x power 2 is a positive number, okay? Now I will substitute by the value of x by the integers numbers which belong to this interval. The integer numbers which belong to this interval are -2, -1, 0, 1, 2, 3, 4, okay? When we substitute by each value of x in this equation, we get the value of y, okay? Then we can label the order pairs in the perpendicular square net like this, okay? Like this. Here I need to find what? I need to find the point of the vertex of the curve, okay? To find the two required here. So here I have 7 order pairs. 5, 5, 0, 0, -3, -3. The difference here, 1 and -4. So the middle order pair here represents the point of the vertex of the curve. So the point of the vertex of the curve is the order pair 1 and -4, okay? Now the maximum or minimum, I said minimum value of the function. So minimum value of the function equals -4, the value of y coordinates and the vertex of the curve. And the equation of line of symmetry equals what? Equals the value of x coordinates and the vertex of the curve. So the equation of line of symmetry equals x is the equation of line of symmetry is x equals 1. X equals 1, okay? Now, another idea, okay? Example number 3. Represent graphically the quadratic function f, where fx equals -x power 2, -x power 2 plus 3x plus 2. X belong to R. Consider x belong to closed interval -1 and 4. From the graph, find maximum or minimum value of the function, the equation of line of symmetry, okay? The same idea here. I will substitute by integer numbers which belong to this interval in this function. So the integer numbers which belong to this interval are -1, 0, 1, 2, 3, 4. Okay, when we substitute by each value of x in this function, we get the value of y, the values of y. So when x -1, y equals -2. When x equals 0, y equals 2. And when x equals 1, y equals 4. And also the same idea as so on, okay? Then we can draw the curve -1, -2, here -1, -2, 0, 0 and 2, okay? 1 and 4, 2 and 4, 3, 2, okay? 4 and -2, okay? Now I need to find the maximum or minimum value of the function. Here is the coefficient of what? Of x power 2 is negative number. So I have maximum value of the function, okay? Here I have 6 order pairs. The point of the vertex of the curve is not among these points. -2, -2, 2, 2, 4, 4. I don't have middle order pair, okay? I don't have middle order pair here. So the point of the vertex of the curve is not among these points, okay? And we can't it is not easy to determine the point of the vertex of the curve from the graph. So I will calculate it by algebraically. Okay. So to calculate or to find the point of the vertex of the curve algebraically, I will find the x coordinates. Okay. So each order pair. Any order pair has two coordinates, x coordinate and y coordinate. To calculate the x coordinate here, I have rule. Our rule is negative p over 2a. Negative p over 2a. The coefficient or the value of p here 3. So negative 3, and the value of a equals negative 1 from the function rule, like this. Okay, the value of p equals 3 and the value of a negative 1. So here x coordinates, okay, equals what? Equals negative p over 2a. So equals negative 3 over negative 2 equals 1.5. So the value of x coordinates equals 1.5. Now I will substitute by 1.5 in the rule function to find fx or the value of y. So when f 1.5 y equals, when x equals 1.5, if 1.5 equals what? Equals 4.25. Okay, the value of x, the value of y. So the point of the vertex of the curve is 1.5, 4.25. Okay. Now the maximum, no, not minimum, it's maximum. Okay, it's maximum value. It's maximum value of the function equals what? Strong. Okay, it's 4.25. 4.25. Okay. Okay. Here maximum. Okay. Maximum. 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 Maximum value of the function equals what? Equals the value of y coordinates equals 4.25. Okay, and the equation of line of symmetry is what? Equals the value of x coordinates. Here x and here y. So x equals 1.25. Okay. Now I finished. Thank you for your listening. Goodbye.